Hello there. In this problem, we're going to do an economic supply and demand type problem where, let's imagine a bake sale, we're selling muffins, and the number of muffins we sell is somehow dependent on the price. And also the expense that we have for running this thing is dependent on the number of muffins that we're going to sell, because we have to buy supplies for them, plus some fixed cost of getting the stand set up, maybe hiring somebody, who knows. So for this problem here, the number that we are going to sell is this linear equation. And if it's free, so if we sell them for free, if we give them away, we're going to sell, we're giving them away, we're going to get rid of 500 muffins. Now if we charge $1, we're going to lose 200 customers, so we'll sell 300 muffins at $1 each, so that's a $300 income. And if we sell them for $2, this is going to be here, 400, we would sell 100 muffins at $2 each, so that's a $200 income. So we're doing a little bit better at 100, although there is this variable cost in there too. Now in general, our equation for income is always equal to the number of people we have show up times the price per person. That's a big topic in these things. It's always number of people times price per person. It's a very overlooked thing. Okay, and I know what the number of people is equal to based on the price per person. So I can write an income equation. Now profit is always equal to income minus expenses, or yummy yummy pie as it is. Okay, so now I'm going to do some substitution. We know that income is equal to this thing, and the expenses, that's this. Okay, and we got to be careful when we write this. This whole thing here, that's my income, and this whole thing here, that's my expenses. And I'm replacing the number of people that you have showing up with the equation for the number of people. And all of that's expenses, so I'm putting all of that in brackets here. I need to subtract everything there. This 50 is going to eventually be subtracted. And this one here, that minus there, that's actually probably going to be added at the end. Okay, well, distribute through. So we'll get rid of that one. And now let's get rid of the negative, the brackets and that negative sign. Okay, doing pretty well. And eventually, let's see here, let's make a little space here. Eventually we can condense this. But I have a typo in here. I got negative 200 p times p, that's p squared over there. Okay, so we got that one right. So this is gathering like terms. The 500 and the 50 makes 550. And then we can add together those other things, get minus 175. So if it's free, we're losing $50 here, and we're losing a quarter for each person that shows up, or each muffin, and that's 500 muffins if they're free. So that's a sizable chunk of money. And somewhere we're going to maximize profit. And the really nice thing is I don't even really need to graph this. I know that I'm going to maximize profit at the line of symmetry. This whole thing's a parabola, and it's opening down because of this minus 200 there. So it's going to have a tippy top somewhere, and line of symmetry gives us that. Maximum profit is P equals negative B over 2A, and this is why we got the profit equation into standard form. So plug those in. Now they're both negative, so eventually this becomes positive 550 over 400, and we can cancel out a 0. We get 55 over 40. Both of those are divisible by 5. We get 11 over 8, and that is 1 3/8, or $1.37.5. And because it's a line of symmetry, we actually, at $1.37 and $1.38, we're going to make the same amount of money, because that's just half a cent away from each of these, so you can kind of take your pick in them. Now, this is not identifying what the maximum profit is. For that, I would have to take this value, or $1.37 or $1.38, and plug it back in here and evaluate, but we were just trying to figure out the price that will maximize the profit, and that is let's say $1.37. We'll sell a bit more that way, generate buzz. All right, thanks for watching. Character and Scholarship for Life.